In this video, we're going to pick up where we left off on the first one by again practicing verifying trigonometric identities. There are two options that I can see for how you might approach this problem. Let's start by looking at the two sides. Remember, our goal is not to solve an equation. I'm going to write that again. Do not solve. We're only verifying. Now, the instructions for this question specifically say to manipulate the left-hand side into the right-hand side. So we're going to do that first. Again, we'll start with our left-hand side, which is 1 plus cosine theta divided by sine theta. So a technique that you may not have seen before, though we did talk about it briefly in class, is to break down our fraction. I can write this as 1 over sine theta plus cosine theta over sine theta. Now, notice that since my goal is to get cosecant theta plus cotangent theta, I kind of already have that. This equals 1 over sine theta is cosecant theta, and cosine theta over sine theta is cotangent theta. So this is the right-hand side of my identity. Now let's say that you're staring at this thinking, I just don't know where to start. But you look at it and decide maybe the right-hand side is a bit more confusing or complex. That's always the side we want to start with. So cosecant theta plus cotangent theta. So the first thing we want to do is break these down into the basic building blocks of sine theta and cosine theta. So I get 1 over sine theta and cosine theta over sine theta. They already have a common denominator, so I can simply add the two quantities. My numerator is 1 plus cosine theta, my denominator is sine theta, and look, that is the left-hand side of my identity, and I'm done. Either approach would work for verifying this identity. The next identity we're going to look at is adding two fractions that do not have a common denominator already. So, let's start by figuring out what our common denominator might be. Again, I'm going to write this aside. My common denominator is going to be 1 plus sine x times cosine x. As of right now, I don't want to go ahead and multiply that out. I can always do it in a later step, but it might be extra work to go ahead and multiply it out that I'll have to undo later. So this means that I'm going to multiply, well, let's start with left-hand side, is cosine x over 1 plus sine x. I'm going to leave a little room because I'm going to multiply it by something. And I'm going to get 1 plus sine x over cosine x here. So I can see that this first part of the expression already has 1 plus sine x in the denominator, so I'm going to multiply by cosine x over cosine x. Remember, guys, don't get lazy and just write cosine over cosine. You have to have those arguments. I'm going to multiply here by 1 plus sine x. So let's see what happens when I actually do this multiplication. I get cosine squared x plus 1 plus sine x squared all over 1 plus sine x times cosine x. So it might help here for us to go ahead and expand that square. So we're going to expand this guy. So that's going to give us cosine squared x plus sine squared x plus 2 sine x plus 1, all divided by 1 plus sine x times cosine x. So if you'll remember, this is kind of like the Holy Grail. We know that this equals 1 from our Pythagorean identities. So we can get 1 plus 2 sine x plus 1 over 1 plus sine x times cosine x. Well, that is 2 sine x plus 2. And I can factor out a 2, which leaves me with 2 times sine x plus 1 divided by 1 plus sine x times cosine x. Remember how I told you not to multiply those? This is why. Look, it's real easy to see that they cancel. We are left with 2 divided by cosine x, which is the same as 2 times 1 over cosine x, which is 2 times secant x, which is what we're looking for, the right-hand side. So we have now verified this identity, and again, it's knowing how to do the algebraic operations and being able to use those proper identities in there when you need to, knowing how to convert things. Let's look at another one. For the next identity that we verify, we need to lean on our even and odd identities. So if you remember, sine and tangent are both odd functions. So you can look up the symmetry of the unit circle and see that if you make a negative rotation, you end up with the opposite sign value, SIGN, of both sine and tangent, whereas cosine, because of the symmetry there, it is an even function, so the negative essentially goes away because the value of cosine negative x is equal to the cosine of x. So for this one, we're going to again start with our left-hand side, and we can see that we have tangent x minus the sine of negative x over 1 plus cosine x. So the first thing we want to do is employ this even and odd identity, which we'll do right here. Now notice that when we do this, we get tangent x minus negative sine x over 1 plus cosine x, which is going to leave us with a positive value here because the two negatives become a positive. So we're left with tangent x plus sine x divided by 1 plus cosine x. The next thing we want to do is write everything in terms of sine theta and cosine theta, so that tangent x in the numerator becomes sine x over cosine x plus sine x divided by 1 plus cosine x. So we need a common denominator in order to add these two. So I'm going to multiply my sine x by cosine x over cosine x. This is going to leave me with sine x plus sine x cosine x over cosine x divided by 1 plus cosine x. So we're going to look at the numerator for a minute, and you can see that there is a sign in both terms of the numerator. So we can factor that out. So the numerator becomes sine x times 1 plus cosine x. That's still over cosine x. Now notice that I'm dividing here by 1 plus sine x. Sorry, 1 plus cosine x. So when I do that division, I actually can multiply this by 1 over 1 plus cosine x, which sets it up very nicely for you to see that these two values cancel. I am then left with sine x divided by cosine x, which is our old friend tangent x, which is the right-hand side of my identity. For the last identity that we're going to verify, we should take a look at it before we actually start to see where we should begin. So notice that the terms are already in sine and cosine. There's nothing for us to change there. There's no fractions for us to combine, and both sides are pretty equally complicated. So there's a technique we're going to use here. We are going to start with the left-hand side. which is sine x over 1 plus cosine x. And what I'm going to do is multiply this by 1 minus cosine x. So remember that if I have the difference of two squares, I can factor it into a plus b, a minus b. This is important here because what we're going to end up with is 1 minus cosine squared x. Sine x times 1 minus cosine x is my numerator, which if you look at the right-hand side where we're going, I want that to be in my numerator. So this is a good hint that we're probably on the right track. Going back to my side work, I know that sine squared x plus cosine squared x is equal to 1, but that means that sine squared x is 1 minus cosine squared x. So that sets us up nicely to make that substitution. So I now have sine x times 1 minus cosine x over sine squared x. One of your sines will cancel here, and I'll make that little mark there. And I'm left with 1 minus cosine x divided by sine x, which is indeed our right-hand side.